Okay, good morning all. Am I audible? Can you see the slide share? Yes, can you see the slide share? Okay, thank you, Priyank. So we were discussing the concept of WS notification and eventing, and I told you the basic difference between notification and eventing is in case of eventing, we have specific messages, right? And that can be sent from either event source to event sync or subscriber to the event source, right? So, and we also discussed the concept of an expiry date, right? Expiry date can be attached to the subscription. So, based on that expiry date, the subscriber can know that when their subscription will be expiring, right? So, everything is again embedded as a part of your SOAP headers, right? So, we are putting more focus on the SOAP headers once again, and we are trying to put more and more information, right, as a part of SOAP headers. So yes, the size of SOAP header would be increasing, but by doing that, you are making your messages intelligent, as well as your services do not have to maintain that information, right? So even Microsoft has supported WS eventing compliant headers that you can see in the second bullet points that will convey all these details, right? What is the expiry date and when the expiration will be occurring, right? We also seen the messages, right, yesterday. So let us just summarize this. So I hope you are clear with these two frameworks. Yes, notification eventing, right, and the concept of publisher subscriber, right? Is that fine to all? Yes. Okay. So let us summarize. Notification eventing, both are, you can say, implementing a single concept. And what is the common goal of both of them? To achieve composability principle, right? Now, by composability, what do we mean is, depending upon the situation, depending upon the scenario, we will be combining multiple services together, and that is going to happen at runtime, right? Remember, we are not statically designing the logic that under situation X, service A, B, and C will be executing. It is not like that, right? It is happening at runtime. Okay. So runtime composability is more important, right? Yes, coordinate whenever required. That's correct, right? So both these frameworks achieve a very important principle of SOA, that is composability, right? And when you do that in a standard way, obviously the quality of service will increase. Do you agree to this? Right? WS notification is a standard, WS eventing is a standard, right? So rather than writing the code or the logic ourselves as programmers, if we follow the rules given by these two frameworks, then obviously the quality would be increasing. Is that fine? Do you agree with that? Right? Okay. So let us look at the arrows. Notification eventing both provide publish and subscribe model for web services, right? So publish and subscribe, remember, that is a concept, right? These two models give you a way in which this model can be implemented. Okay. And very important aspect, either you use notification or eventing, right? That does not matter, but you have to use addressing, right? Remember that concept? We have discussed that yesterday, right? Ultimately, you need to know where your message is going, right? Or from where the message is coming, right? And it is the WS addressing specification that ensures the proper information in the message headers. Okay. So can I say that notification eventing depend upon addressing in some sense, or they have to use addressing for achieving the goal, right? So multiple specifications are related, right? Even in this case, do we require security in some sense, WS security? Because again, you will be, let us say, checking whether your subscriber is valid or not, right? So security is also required, right? So yes, multiple standards are related to each other. Fine. Okay, so this is the example, right? You can just have a look at this. Yes. Why it is not directly giving us loose coupling, as it is giving us when we are using broker. Okay. So, as I understand your question, let me ask it once again. It is, are you saying that when we are using broker, you are not having loose coupling? Is that so? Udit? Okay, in previous slide. This slide? Okay, you are talking about principle. Okay, okay, okay. Yes, I got your question. Yes, yes. So loose coupling is not directly achieved over here. See, because see, there is a trade-off over here. In case of notification and eventing, you are having, let us say, communication between services, right? Do you agree to that, right? And the communication would be slightly higher than normal interaction, right? Because whenever you are broadcasting the messages, the amount of communication that takes place is higher, right? Okay. So by doing that, loose coupling, we should take care that loose coupling is not violated, right? I hope you agree to that, right, Urjit? Because see, as the communication increases, it is possible that the coupling might increase. Yes or no? Are you getting the point? As the communication increases, or as the amount of communication increases between services, we have to make sure that they remain loosely coupled, right? Is that fine? Right? So loose coupling is not achieved by this framework, right? That's what I wanted to be clear, right? Loose coupling is not achieved by this framework, but actually, when we are using notification eventing, we have to take care that it is not violated. Okay, I think you are clear. I think others are clear with that. So what is highlighted over here, what is in bold fonts, or you can say the black fonts, is the principle which we are achieving by using this framework, right? The other principles are indirectly achieved, or we have to achieve them programmatically by some means, right? Loose coupling we have to take care of, right? So that is why it is not highlighted. Okay, fine. Are you all clear with this now? These two standards, notification eventing and SOA, right? So this ends chapter 7, as I said. So we have, or actually we had covered few topics from chapter 7 in second sessional phase, and we have covered the remaining topics in the third sessional phase, right? So I'm uploading the slides session wise. So I hope there is no confusion, right? Whatever we have covered after the second sessional will be there in the syllabus of third session, right? So chapter 7, this portion, MEPs, then, or you can say the first topic that we covered was notification eventing, or you can say security, and these concepts will be a part of your third session, right? Now we are going for the next chapter. Okay, but before that, let us have a look at this example. So you have two companies, Railco TLS. TLS has a subscription service, right? And TLS has a notification service, right? Now, why it is required? As I said yesterday also, suppose invoice service would like to know how many bills have been processed, right? So for that, it can subscribe, yes or no? Invoice service of Railco can subscribe to the TLS for getting updates regarding invoice processing, right? So in that case, your invoice service would be acting as a subscriber, and on the other side, you will have a notification service which will be acting as a publisher. Okay. So if you think in terms of role, this system notification service is acting as which service? Is it a publisher? Is it a notification producer or anything else? Let me check how many of you remember yesterday's class. Publisher, okay, in terms of, yes, Priyank, I'll repeat, surely. So in terms of WS notification, if you think, right, right? Remember that in case of WS notification, we had the services like publisher, then notification producer. Remember that concept, right? So with respect to that concept, this service, system notification service, plays which role? Is it a publisher or is it a notification producer? Prince, according to WS eventing, your answer is correct, right? Event source is fine according to WS eventing. But what about WS notification framework? WS notification says that publisher generates notifications, right? And notification producer handles the subscription request and it sends the notification. So yes, we can say that right now we don't have any, you can say, special publisher available over here, right? It is not visible in this example. So we'll assume that this service is combining two roles, publisher as well as notification producer. I hope Dave, will you agree with that? Because we assume that publisher is not there, right? If publisher is there, then your answer would be correct. Then this service would be notification producer, right? So what this example says is, you can convert any service of your framework, any service of your application as a publisher or as a notification producer or any other role. Is that fine? Right? So you can again see the situation, right? TLS subscription service is sending the request and it is requiring update regarding what, right? So in the SOAP message, it will write down that I want update whenever metadata of account service changes, right? Because if metadata changes, why do we need to get that update? Yes. Just refresh the concepts of first sessional as well as some portion of second sessional. Why do we need that the metadata, updated metadata should be given to us? Okay, what do you mean by updating the metadata, or what can change in your metadata ideally? WSDL, correct, right? And WSDL means basically, suppose initially we're supporting 4 operations. Yes, policy may also change, correct, right? But more often, your operations will be changing, right? Either you will be changing the operation signature or you might be adding new operations, right? Remember that concept? We discussed all these things earlier, right? So that is called changing the metadata, right? Either the rules are changing as Prince has written, policies are changing, or you are changing your interface, right? In any case, you are interested in getting the updates, because if you don't get the latest wisdom, it is possible that your request might fail, right? So that is one request we are sending. And then we are also requesting for changes of purchase order service, right? Whenever there is a change in metadata of purchase order service, TLS should be notified, right? So by doing this kind of behavior, again, I'm going back to the same principle of loose coupling. Can I say that we are indirectly achieving loose coupling? See, we want only changes. So whenever changes occur, only at that point you will be notified. Until that, are you going to be connected to TLS permanently? No. And when we say that we are not remaining connected throughout, are we achieving loose coupling? Yes, right? So I think, Urjit, now you agree with this point, right? Loose coupling is or has to be achieved, right? By doing something, right? And this is the way by which we can achieve it, right? So it is indirectly achieved, right? Not directly. Okay, so I think this is sufficient for this. Now let us go for the next chapter. So next chapter is principles of service orientation, right? So we need to answer a few questions before we go for that. How can we build web services that are truly service oriented, right? So what is 1 point answer for this, according to whatever you have studied in chapter 1 to 7? Yes, correct, right? We have to realize the principles, right? And we have to understand, we have to implement them practically, correct, right? So that is the second part of this chapter. The answer to this question will be given in the second part of this chapter, chapter number 8. The first part of chapter starts with this question: which are the primitive components of SOA, right? If you remember the first or second lecture, right? What are the most basic components that you require to implement an SOA? Yes, correct. Service. Service has description. Yes, we can say that. Inside service, what do we have? If you go in depth, messages are required, correct, for communication. Interface, or you can say interface has operations, right? So if I try to find out four terms, right? It can be service, right? Service contains operations, right? Operations exchange messages, right? And under which scenario the messages are exchanged, that's what we call as activity. If you remember that concept of service activity, right? When two services are interacting with each other at runtime, that is known as service activity, right? Like invoice is interacting with the account, or account is interacting with the ledger service, and so on. So can I say that these four components, right, are the basic aspects of SOA? What I've written in the chat box, right? And there is a relation, right? Service contains operations, operation contains messages, and activity actually covers services, multiple services. Do you agree to this? Remember this, right? Basics, because these are the primitive components, or you can say basic components of SOA. Now, if we say interface is a part, so interface is a implementation aspect, right? But interface implements what? Interface implements your operations, right? Yes or no, Priyank? So interface is a implementation aspect, while operations is a conceptual aspect, right? And yes, I had one more answer. Yes, Prince has written description. So yes, ultimately description has to be shared, right? So description can also be a part of this primitive component, right? But basically these four are known as primitive components of SOA. So we have answered two questions. How can we build web services that are truly service oriented? The answer is make sure that those 8 principles are fulfilled. Okay, so we are going to have a lot of discussion. Hopefully, it is not going to be one way, right, on the service orientation principles in the second portion of this chapter. And today, I'll be starting with this components of SOA, right? In brief, we have to touch upon that concept. Okay, fine. So look at this example which is given over here. So what do you understand by this boxes which is given at the top? And it is labeled as business processes. It looks like what, or which diagram that you have drawn in earlier semesters? Correct. Flowchart, right? Correct. So basically, can I say that the rules that I'm capturing, or you can say the requirements that you are capturing for a software, are your business rules? Ultimately, requirements are nothing but business rules, isn't it? Right? Because we have to implement as per those rules which are mentioned in the requirements, right? Yes. One out of the topic question is, if we strictly follow policy, we are always going to follow the principles. Okay, that's a good question, right? See, policy is actually the business policy defined by the organization. Like if I say that, if you want to communicate with TLS, you have to use this style of encryption, right? Or you have to use this style of authentication. That is a policy that I'm establishing. But that does not mean that you are satisfying the principles, right? Principles are embedded within your code. It is not a part of policy. I hope you are getting the difference. Yes? Yeah, sure, sure. See, basically, I gave you the example over here. That is, if I'm setting a rule that if you want to interact with account service, you have to use a certain type of authentication, like you have to use WS security. Okay. So, can I say that you are following a principle over there? Or would you say that you are following a rule over there? It is a rule, right? And rule is what? Policy, right? But what if you are, once you, let us say, perform authentication with that service and you remain connected with that service for the entire period of interaction, can we say that are we satisfying the loose coupling principle? No, right? So policy and principles are not related. Principles are there in the implementation. We have to realize them through implementation, while policies are plain rules that you define, right? Clear? Yeah. Okay. So if you focus on this figure now, business logic is nothing but your set of requirements that we write. Do you agree with this? All of you have written requirements many times, right? Now, since your fourth semester, you are in sixth semester, right? So ultimately, we are writing requirements because we are trying to capture rules, right? So that is called your business logic, right? But ultimately, when this business logic will become realistic, when we implement it, yes or no? Ultimately, we have to code it, right? So the first thing that we capture is business logic, right? No matter what kind of software you are building, right? Either you are building a software or you are building a service oriented application, right? You capture your business rules first, or that is called a business logic. And then you try to realize those business rules by implementing one or more applications, right? One or more applications. So if there are a lot of business rules, then you might be implementing them as multiple applications, right? Like over here, you can see there are 3 applications that are trying to realize the business logic that is mentioned. Okay. So can I say that application logic is the implementation of business logic? Or in other words, application logic is the implementation of your business rules. Yes or no? I'll repeat. Business logic defines your rules, right? So can I say that the application logic that you are coding is going to realize business logic ultimately, or it is the implementation of your business logic? Yes, right? So I think you might have heard of these two terms, right? Very often. We say that this is my business logic and this is my application logic, but business logic is always on paper, right? When we convert that to code, it becomes application logic. So are you clear with the relation? How these two logics are related? Right? Because when we are implementing an architecture, first of all, we have to capture the business logic, or you can say business requirements, right? And then we have to find out how we can realize those rules by implementing services. Okay. So let us look at the definitions now. Yes, correct. It is abstraction like structure. So we don't want to expose the business rules directly. We expose the business rules through the applications. So you can say it is abstraction, right? Okay. So you can, in some sense, you can also say that your SRS is one way to provide your business rules, right? SRS mentions your business rules, and when you deliver both the things, your product and SRS, right? Ultimately, your customer would be looking at the product, but what you have realized in the end, business rules, right? Okay, so that is the relation. Fine. So, what is the definition of business logic? This is immaterial, or you can say this is independent of the subject, right? No matter whether you are studying SOA or any other programming subject, this definition is going to be common. So, you remember this. It might be useful for your interviews, right? Business logic is documented implementation of business requirements, right? Why do we say documented implementation? Because we write that as document. Are you getting this? Right? We write the business rules in form of a document, and that is why it is called business logic, right? How do we express business logic? Business logic is generally expressed as requirements along with associated constraints, dependencies, and outside influences, right? So let me go out of this subject. How do you capture the constraints or dependencies across your requirements? Which document or which part of your documentation will be capturing that? Can I say your diagrams will be supporting in this way? Class diagrams, sequence diagrams. I think those who are working with SDP might be preparing them right now, right? Yes or no? Sequence diagram, if you remember, it captures the interaction between objects. So can I say that you can look at how your classes or objects are related or they are dependent on each other? Yes or no? Are you able to relate or not? Yeah. So basically, I hope you remember the concept of software engineering where we studied that SRS is not only enough, right? SRS plus you need one more document, right? That is called as design document that has your set of diagrams. So if you combine these two documents together, it collectively represents your business logic. Agreed? Yeah. Okay. So this is business logic. If someone asks you this, what is business logic as a standard question, this is actually a common general knowledge as a computer engineer we should have. This is the definition you can remember, right? Now let us see what is application logic. Application logic is automated implementation of business logic. Automated implementation. Remember, when we say we are automating, when we are programming, right? So ultimately, you have to convert the business logic in form of code, and that is called application logic, right? Some people also call that as automation logic, right? I think we can use these two terms synonymously, right? Automation logic or application logic. Ultimately, it is nothing but your code. Fine with that, right? So what application logic contains? It expresses business process workflow, right? Through purchased or custom developed system, right? Either you can buy the off-the-shelf component. Again, I'll take you back to software engineering. We had seen a concept, or you can say a model of component-based development. Remember that concept? Suppose you are interested in accounting software, so you go to some company which is selling the accounting software and you buy that off the shelf, right? I hope you remember that example at least, right? So either you are purchasing that from someone else or you are developing that yourself. That is called custom development, right? Within the confines of a single organization's IT infrastructure, right? So it is a specific company which is building this, okay? Plus you might also have the security constraint, technical capabilities, and vendor dependencies. Like if you are using .NET framework for building, then you can say that you are sticking to one specific vendor, okay? So ultimately, application logic can include the aspects like your application code, your technical framework details, security details, and the IT infrastructure, right? Clear? What is application logic? What it contains? right? Okay, so ultimately, uh, can we say that one type of logic is more important? Can I say that business logic is more critical or application logic is more critical? Or you would say that both are equally important? What do you think? As far as any application is concerned, both are equally important, right? Because if you don't write your requirements properly, you have studied the theory, right? What may happen, right? And vice versa. If you don't use proper technology for implementation, like if you don't focus on the coupling aspect, if you don't focus on the statelessness aspect, ultimately, no matter how good your requirements are, but you will be implementing a coupled solution, so that is not going to work, right? So both are important. Yes, fine. So I just wanted to clear this out before we go for the figure, that is this one. Now observe this. Why we have inserted set of services in between, right? Because if you remember one concept, now I'm in the same subject, right? It is orchestration. What was the goal of orchestration? Or if you are having a process service, what is the goal of that service? It defines the rules. Can I say that? Yes. Similarly, if you think about the coordinator, WS coordinator service, right? Again, it was defining the collaboration rules, right? Okay. So can I say that orchestration service or coordinator service are actually representing your business logic in one sense? Try to relate these two aspects, right? Okay. So the service that you can see at the top of the tree, can I say that it is going to be the orchestration service or it is going to be the coordinator service? Although it is not a proper tree, but I think you can see the root element, right? Not a pure root like we have in tree. But can I say that the service at the top is actually a coordinator service, right? And it is placed near to the business logic. Are you getting the reason why? Right? Okay. So the services which are at the bottom, right, what they will represent then? Services at the leaf level, what they will be representing? Yes, they will be representing the application domains which are at the bottom, right? You have three applications. Application A that is implemented using .NET, application B implemented using J2EE, application C is legacy. As you know, if you want to implement an SOA, we have to provide a generic interface, yes or no? Can I say that this service is going to expose only .NET based services, or this service is only going to expose Java based technology? No, right? What we want is a standard behavior. So the services that you can see at the leaf level are actually extracting these three applications. Are you getting that? And they are exposing the logic in general way outside. Okay, right now I won't be able to show you the example because this is the diagram, but I hope you're getting the concept, right? Yes, Priyank is clear. What about others? I'll repeat once again, right? See, the service at the top, we can say that it is orchestration service or it is a coordinator service because it is going to represent your business rules, right? But those rules are going to be followed by the lower level services, right? And those lower level services are actually extracting the existing applications. If you remember the contemporary SOA characteristic that I discussed in the, I think, second or third lecture, we don't prefer throwing away existing applications. Remember that concept? We don't prefer throwing away existing applications. Rather than that, what do we prefer? We prefer that we design wrapper kind of services that will expose my existing technology in a standard way. Yes, you will hide the legacy as a wrapper, right? Correct, Priyank, right? Even if you are having a .NET based application at the bottom, Java based application at the bottom, but ultimately what you will be showing outside XML, right? So no one will know. Yes. It is also it can also be called as a choreography service if you are talking about two organization combined. But right now we are you can say we are talking about only one organization. So that's why I would say that it is orchestration service. Right, Prince? Yes. So there's a difference. Choreography is beyond the organization, right? While orchestration is within the organization, right? So that's why I'm saying that this is orchestration service. Okay. So now I think all of you are clear. Why do we insert services in the middle, right? In the middle of business and applications, right? Because we want to hide the technology, right? And we want to expose the generic behavior outside. Clear with that? Okay. And this layer is known as what? The short form you can remember as SIL, full form service interface layer. I think you can read that, right? The middle layer is named as service interface layer, right? The topmost layer is called as business process layer, where you write your requirements, right? And in the bottom you have actual existing code, right? That is your application logic. Okay. So by doing this, we can actually hide the implementation details and we can show only generic interface. So can I say that if we achieve this kind of architecture, most of the principles would be fulfilled? I'm not naming the principles right now, but can I say that most of the principles would be fulfilled? Right? Because you are abstracting, so abstraction is there. If you design the services in loosely coupled manner, loose coupling is achieved. If the logic is proper, autonomy is achieved, right? So our goal is to focus on the middle tier. As an SOA architect, our goal is to focus on the middle tier. How you will expose your logic, that is the challenge, right? Okay, fine. So I hope I have made sense with these topics. Now, let us look at more details, right? We imagine or we assume that the services at the bottom level are exposing the, you can say, actual technology. You can see the first service on the left hand side, bottom service, is exposing two boxes of .NET application. The second service is exposing only one box of your .NET application. Similarly, in the second, you can say subtree, you have one service exposing the one module of J2E application, right? So this depends upon how many components you want to integrate, right? I can also design one single service to expose my entire application A, right? Or I can design individual services for individual components, right? Which would be better? Which would be better? Now I think you are in a position to answer this question after studying all these concepts. I'll ask the question once again. Should I combine entire application A in one service, or should I go with proper subdivision? That is one service for one component or one service for at least two components. Subdivision, correct, right? Because that is going to be more manageable, right? Maintenance cost would be less, plus coupling will decrease in this case, right? Okay. Okay. I think this violates loose coupling and generic services. Yes. It violates reusability in some sense, but it depends upon what, Priyank? It depends upon how you combine or how you compose the components, right? See, if you compose one component in one service, that is going to be the best case, isn't it? right? But sometimes two components of your application A are related to each other. So we have to merge them together in a single service, isn't it? As done in the first example, right? So we have to strike a balance, right? Ultimately, reusability should be achieved, loose coupling should be achieved, right? But if your underlying framework is such that you are not able to achieve those principles to 100%, then we can accept, right? But at least you are able to achieve 90% loose coupling, we can still say that we are implementing a service orientation, right? Because we cannot change the underlying code, right? I hope you get that point, right? If you change the underlying code, you will have to rewrite the code, make it loosely coupled, right? So a lot of effort would be invested in that, right? So we have to compromise to some extent. Okay, is this example clear to all? Okay, now I think you understand why legacy application is exposed via single service, right? Can I have a scenario where the legacy application is exposed via multiple services? Is it possible even? Remember the properties of legacy application? It is a very old application. It is highly coupled application. It is using older programming languages, right? So will there be any point in splitting that application in multiple services? No, right? Rather than that, you will go with a single standard service that will expose your entire legacy application, right? So that's why you can see there is a big box over there. Is this point clear, right? Regarding application C? Okay, fine. So it is up to the SOA architect to decide how many components you will be integrating in your service, right? You have to take care of loose coupling and reusability, as Priyank has already mentioned, right? But sometimes we have to compromise some of the principles, right? But we cannot compromise the principles at 100%. You have to satisfy to some extent each principle, okay? 100% accuracy is never possible, right? Same way, 100% achieving of service oriented principle might not be possible, right? But we should try our best. Okay, fine. So now let us go for the next topic. So now I'm going to cover 3 topics over here. Let me list down them in the chat box first. Logical components of web services framework. The second concept that is going to be logical components of automation logic. I already said automation logic or application logic. You can, yes, square box is component, you can say, or you can say a package in terms of Java, right? In terms of .NET, what will you classify this as? In Java, if we have a package with respect to .NET, you can say namespace, yes, right? Or you can say an assembly, right? A single assembly that you created, right? Yeah. So comparable level of abstraction, basically, right? I'm not talking about at class level, right? We are talking at higher level. Okay, fine. The third topic that I'm going to cover will be components of SOA, right? So these 3 topics I'll be covering in the remaining time, right? So let us start with the first set of components, logical components of web services framework. Whenever you want to implement web services, you require 4 ingredients like a recipe, right? The first thing you require is web services themselves. We have already seen this in chapter number 5. This is just a revision before we go for principles. Second thing that we require is operations. Third thing that we require is messages. And finally, we have activities, right? Can I say that service activity happens at runtime or it happens at design time? Just try to recall. I think I also discussed that few minutes ago. Service activity is interaction between two services, right? It happens at runtime, correct? Right? At design time, we don't decide which two services would be interacting, right? Depending upon the situation, you will be calling a service, right? Okay. In terms of levels, if I say, which one you will put at the highest level out of these four? Which one you will put that contains others? Service contains operations, or operation contains messages, or activity contains services. What is the highest level? Prince has given one answer. Would anyone else like to try? I hope the question is clear. Which is at highest level, or which component can I say is covering the others? Okay, Priyank has the answer is activity. Activity contains services. Yes, definitely, Urjit, because activities will compose the services dynamically, right? Like invoice is calling account, right? So activity is your answer, right? Urjit has given an answer. What about others? Activity, service, operation. Okay, Deep has given the complete answer. Yes, yes. So that is the correct way. I hope the others will agree to that. Those who replied, Prince, Priyank, Urjit, right? So yes, that is the relation, right? Activities actually contain more than one services. Services contain operations. Now, how you are implementing that is immaterial. You are implementing that using interface or any other technology, right? Operations work based on messages, right? As you have already seen in WCF, I think in WCF you have seen your WSDL files, right? In WSDL file, we had an element of operation. Remember that operation XML element? An operation contains which sub element? The hierarchy was like this, right? Inside service, you have operation, right? And inside operation, you have message, right? So same hierarchy we are trying to map out over here, okay? So that is the relation between these four components. If you want to implement web services for SOA, these four components are necessary, right? Why they are called logical? Because still we are talking about theoretical concepts. We have not talked about implementation. That's why they are logical components. Fine. Are you clear with these four components of web services framework? Right? So this further slides will make you more clear. Services contain one or more operations, right? And what these arrows signify? Can anyone tell me? Suppose you have written, let us say, get employee. I think you have written that code, right? Get employee. So get employee requires a request message and it responds with the employee details. So it is a request response. So it is an MEP actually, right? It is a message exchange pattern, right? And we can also say that it is containing messages, right? So if I go one step further, operation or through the operations, you can send the SOAP messages, right? You can see this arrow, if it is going outside, that means it is an outgoing SOAP message. If the arrow is inward, that means you can say it is an incoming SOAP message, right? So each operation governs the processing of a specific function, right? Functions are implemented as operations, right? We all know this. Operation contains sending and receiving of SOAP messages, right? And finally, if you combine these components together, and if you put two circles on each side, can I say that this is an activity? Right? We have not labeled them, but ultimately it is an activity, right? So by composing operations and messages, we are actually forming an activity, right? An activity is always dynamic in nature, right? But I want to discuss an important difference over here, that is activity versus process, right? Process in the sense of the orchestration. If you remember the process service was defining the rule that under this situation, service X will be called. Under this situation, service Y will be called. Remember that situation, that kind of example of orchestration? Okay. So, listen to my question and try to answer that. What is the difference between activity and process? We know that activity happens at runtime, so it is dynamic in nature, right? What can you say about process? Can you write the difference on the other side? Can I say that process is a static rule, or process is static in nature? Fixed set of rules, correct, right? Correct. Others, do you agree with this answer? Right? So, if you are asked this in exam somewhere, what is the difference between process and activity? So, activity happens at runtime, right? We don't know which two services will be interacting at runtime, right? But process is something which we define statically, right? Okay, so that is the difference between process and activity. We will see process term very soon, so that's why I cleared out this concept. Okay, now let us go for the next topic: logical components of automation logic or application logic, right? So in terms of implementation, what do we call these four components? I'll repeat. In terms of implementation, what do we call these four components? And when I say these four components, that means it is service, operation, message, and activity, right? So when we are actually implementing, SOAP messages are acting as units of communication. Do you agree to this? In terms of implementation, in terms of your logic, SOAP messages are units of communication, right? Your operations are units of work, because ultimately that is the work that you are achieving. Do you agree with this? Right? Or that is a logic actually, right? That you are writing. Second point, clear? In terms of implementation, operations are unit of work. Your services are units of processing logic, right? Ultimately, service contains operation, right? So if I say that, if I combine units of work together, if I combine units of work together, will it form a service? Okay, what is units of work? What is units of work? It is operation. Clear up to that? Right? And if you combine multiple units of work together, can I say that we are having a service? Yes, message also required. Yes, yes. Message is internally present. So we assume that, sorry, Prince, right? Yes. Okay. Now, next is process, right? So process is actually one instance of an activity. Can I say that? Process is actually one instance of an activity, because see, activity happens at runtime while process is defined statically, right? So at one time when the activity is occurring, can I say that one instance is taking place? One instance of interaction between invoice and account is taking place, right? So here we have the concept of process, right? In terms of implementation, process are units of automation logic, or it is also called coordinated aggregation. Understand this term carefully. Coordinated aggregation of units of work. Why it is called coordinated aggregation? Because depending upon the situation, you will be calling one or more operations. Yes or no? Depending upon situation, you will be calling one or more operations. Yes or no? And where do you define that rule? Inside a process? Where do you define a rule that under this situation you will be calling this service inside a process? So that is the highest level. That is the highest level. Clear? Right? So process composes web services composes messages and operations, right? And that is how we implement our logic, right? So this is why these four are called logical components of automation logic. I'll repeat once again. In terms of implementation, we call them as SOAP messages, right? Or in terms of web API, you call them as HTTP request and response messages, right? Okay, ultimately you are embedding the technological aspect with the name, right? Clear? Then when you are implementing your classes, right? The classes contain operations, right? But operations are nothing but your logic or units of work, okay? The classes are part of your web services, right? But ultimately, what are web services? They are collection of units of work, okay? And you have defined certain rules for those web services, right? Let us say you have implemented an orchestration service, right? So that is called a process. Fine with this now? Okay, we have tried to relate implementation aspect with the theory. So that is the important relation we need to understand, right? Finally, if I go back to the last topic for today, this figure I think you can easily understand now. Every service is a collection of multiple units of work, because you know multiple units of work means multiple operations, right? And if you combine two services, it forms your automation logic, right? Okay, fine. Then the last topic is this, components of SOA. For SOA, what is the meaning of message? What is the meaning of operation? What is the meaning of service? Right? That we need to complete and then we'll stop. I'll be starting with principles next time. Okay. So for SOA, message represents the data. Do you agree with this? SOA is at conceptual level, right? So for SOA, message is nothing but your data, right? What operation is for SOA? Operation is nothing but the logic required to process the message. That's it. Right? Agree to this? Again, at conceptual level, we are talking, right? Not at implementation level. Okay. Service represents logical grouping of operations, right? For SOA. Fine. And process defines the business rules or your business requirements or business logic. Okay. Now, if I go back, so which thing you should design first? Components of SOA we should think about first, or components of automation logic we should think about first, or components of web service framework we should think? As an SOA architect, which component set you need to design first? With that answer, we will stop today. Yes? 3 options. Will you be going for components of SOA selection first, or will you be going for components of automation logic first, or you will be going with components of web service framework first? Okay, which is at bottom level? Which is at bottom level? Implementation? Yes or no? At bottom level, we have implementation, right? Implementation is represented by which components? These components, automation logic. Yes or no? Right? So automation logic will be decided at the end. Do you agree with this, Priyank, Urjit, and others? Right? This automation logic components are mapped actually with web services framework components. So I think this will form at middle level, or this will fall at middle tier, right? And at highest level, what comes? Your requirements. Yes or no? At highest level, We have your requirements, and that is nothing but components of an SOA. Agreed? Clear with the relation of these three set? Yes, Surjit. I think that would be the correct way to represent. Others are clear? Yes? Okay, so we are done with the first part of chapter 8. From next week, I'll be directly jumping into the principles, right? And we'll have a discussion on that, right? So thank you. Let us end this session for today. Have a nice day ahead.